Hello students, today I am going to give a MCQ based on bioinstruments. Before going into the video, I just want to say, just read the textbook twice. It will help you to find your own MCQ. Here I am giving the support, but I hope you will read the textbook and you will try to find your own MCQs. Let us begin the video. So, bioinstruments, and the bioinstrument is based on two very famous law, that is Beer's and Lambert's law. Before going into Beer's and Lambert's law, first you should understand what is Beer's law individually, then Lambert's law individually, and after that Beer's Lambert's law. So the bold words indicate MCQ. They can ask MCQ. Again, I will repeat. Just read the textbook; it will help you out. And here comes the Beer's law. The amount of light absorbed is directly proportional to concentration of the solute in the medium. So we are going to take some medium, and in that we are going to incident ray of light. A part of the ray will be absorbed, and the other remaining part will be transmitted out. And the amount of light absorbed, it depends on, it is directly proportional to the concentration of the solute. If the concentration is less, then less amount of the light will be absorbed, and if the concentration is more, then more light will be absorbed. Hence, the amount of the light absorbed is directly proportional to the concentration of the solute in the medium. जो bold लिखा है, there are chances वो MCQ में आएगा. Now, Lambert's law. The amount of the light absorbed is directly proportional to length or thickness of the solution under analysis. If we are taking a narrow tube and in that we are keeping our solution under analysis, then the amount of the light, less amount of light will be absorbed. If we take a very big container and in that we are incidenting, then it will the amount of the light, more amount of light will be absorbed. So amount of the light absorbed is directly proportional to, either we can say the length or the thickness of the solution under analysis. Length means here solution is in liquid form, so we are going to take test tube, and the test tube, the diameter of the test tube will indicate how much amount will be absorbed. If the diameter of the test tube is less, then less amount of the light will be absorbed. If the diameter of the test tube is more, then more amount of the light will be absorbed. And A, that is the amount of the light absorbed, is directly proportional to L, where A is the absorbance and L is the length of the medium. Now, combining the Beer's and Lambert's law. When we combine the Beer's and Lambert law, we will arrive to a final equation, that is absorbance is directly proportional to epsilon C into L, where epsilon is the existence coefficient, C is the concentration of the absorbing particle, and its unit is very important. Sometimes they ask the unit, so mole per liter, and L is the length in centimeter, and if it is equal to 1 through which the light passes, then A is equal to epsilon into C if L is equal to 1. So based on this equation, you can get numerical 1 mark question. MCQ based numerical can also come. Here there are chances of getting numerical. Here is a solution, and we are going to incident a particular wavelength, and in that some solute is there. It will absorb the things and rest will be transmitted. So it is a fraction of the incident light that will get transmitted out, and hence it is called as transmittance. The fraction of incident light that get transmitted through a medium is called as transmittance. If the intensity of incident light is I0 and transmitted light is IT, then transmittance is given by IT by I0. Either MCQ fill in the blank you will get, or the numerical based on this you will get. Absorbance A. Absorbance A of the solution is measured in terms of optical density, OD, and it is related to the transmittance. Okay. So the relation between absorbance and transmittance is A is equal to minus log T, and we also know T is given by IT by I0. So we can write, and we will get equation A is equal to minus log T is equal to minus log IT by I0, where IT is the transmitted intensity of light and I0 is the incident light, and which can be written as log of I0 upon IT. Since minus is there, so we can change. We know the logarithmic rule. and according to that minus log IT by I naught is equal to log I0 upon IT. And the relation between these two, transmittance and absorbance, there exists a inverse relation. These two are inverse, since negative sign indicates they are inverse to each other. So inverse correlation between absorbance and transmittance means higher the absorbance, lower the transmittance, and lower the absorbance, higher will be the transmittance. Absorbance of a solution, here we are going to absorb the light, and we are going to take concentration of the solvent will be equal to 1 gram per liter, and we are going to place in a earlier slides I mentioned the test tube, but here we are going to mention it as a cell. So we are replace the test tube by a cell, and the thickness of the cell is 1 centimeter. So absorbance of a solution having concentration of 1 gram per liter placed in a cell of 1 centimeter thickness is called as absorptivity or extinction coefficient. It is denoted by epsilon, and the formula is epsilon is equal to A upon C into L, and the unit, very important, note down, liter per gram centimeter or dm cube per gram centimeter. Sometimes they can ask the units also, so be clear with extinction coefficient. Its unit is liter per gram centimeter or dm cube per gram centimeter. Our extinction coefficient, it is denoted by capital E. Another name for that molar extinction coefficient is molar absorptivity. Then the concentration, here the name molar indicates we are going to take 1 mole per liter. So concentration will be 1 mole, that is 1 mole per liter, and the path length of the light we are going to take is equal to 1 centimeter. Then it is called as molar extinction coefficient. It is denoted by epsilon. It is written as E because I was not able to get that symbol. So in a fast mode I am doing all this thing. So this is not E, this is epsilon. So absorbance A is equal to epsilon into C into L. And so epsilon is equal to A upon C into L, where here in the C concentration will be equal to 1 mole per liter and L will be equal to 1 centimeter. When this both things are equal to 1, then epsilon will be equal to A. And the value of molar extinction coefficient epsilon depends on the nature of the absorbing substance, solvent, and wavelength of the radiation. These are the 3 important things. They can ask the true or false based on this. And the unit of molar extinction coefficient is liter per mole centimeter or dm cube per mole centimeter. So here there is a possibility of more correct answer, more than one answer, correct answer you are going to get. Some multiple choice question will be like that, more than one answer will be correct. So in that, here the epsilon depends on nature of absorbing substance, solvent, and wavelength of the radiation. So remember this. Radiant power, it is denoted by P, and it is intensity of transmitted light. The definition of radiant power P is intensity of transmitted light, and it is also denoted by I suffix T. Radiant power P suffix O, it is intensity of the incident light. When we are going to speak about the intensity of the incident light, then it is denoted by radiant power P naught or I naught. Absorbance, it is denoted by capital A, and the formula is log IT by I0. And another name for absorbance A is optical density OD. Then comes the transmittance T. It is denoted by capital T, and the formula is IT by I naught, or in terms of P, that is the radiant power P upon P naught. Thickness of the media, that is P. It is another name for thickness of the media is path length. Absorptivity, it is denoted by A. Another name for this is extinction coefficient, denoted by epsilon. Here again E I use, and the formula is A upon C into L, and its unit is liter per gram centimeter or dm cube per gram centimeter. Molar absorptivity, another name is molar extinction coefficient, and the formula is epsilon into molecular weight. Here there is a possibility they can ask a numerical based on this formula, and the formula is A upon molar extinction coefficient is equal to A upon C into L, and in terms of liter, the unit is liter per mole centimeter or dm cube per mole centimeter. Don't forget to write the proper unit. Now we are going towards the calorimeter. So what is calorimeter? It is a device that measures the intensity and wavelength of the light passing through the substance in a liquid. It measures the relative absorption of the light by the substance with reference to the light absorption by the liquid. Calorimeter, as the name indicates, it is a color meter. Here you need to use a colored solution, and in that solution we are going to incident certain light, and as a result, as I already told, certain amount of light intensity will be absorbed and the rest will be transmitted. And this apparatus is based on this effect only. And this device is mostly used to determine the concentration of the known solute. Some known solute is there, and if you want to measure the concentration, then we are going to make use of calorimeter. And here they are making use of Beer's Lambert law. As I already told, Beer's Lambert law governs is the major principle behind this calorimeter. Spectrophotometer. Now calorimeter just now we saw. Now another instrument is spectrophotometer, and in spectrophotometer is a device measures the amount of the photons that the intensity of the light absorbed after passing through sample solution. With the spectrometer, the amount of known chemical substance concentration can also be determined by measuring the intensity of light detected. Depending on the range of the wavelength of the light source, it can be further classified. It is having certain more types. But calorimeter, color solution we are going to make use, and in spectrophotometer, there is no such specification that we should give a color solution. But here chemical substance, you can find the concentration. So whatever I made bold in this, there is a possibility that it can be asked as a MCQ. So spectrophotometer is a device that measures the amount of photons, that is the intensity of the light, absorbed after passing through the sample solution. Spectrophotometer is further classified into two types. First is UV visible spectrophotometer. In that, they are going to make use of ultraviolet range, that is 185 to 400 nanometers, and visible range, that is 400 to 700 nanometer of the electromagnetic radiation spectrum. And the second type of spectrophotometer is IR spectrophotometer, and IR indicates the infrared range. Here they are going to incident the solution with the IR ray, then the range of that IR radiation is 700 to 15,000 nanometer of the electromagnetic radiation spectrum. So spectrophotometer is classified as two types. First is UV visible spectrophotometer, based on which ray they are using. Here ultraviolet and visible range they are using. And the second type is IR spectrophotometer. Here they are using infrared range, and in MCQ there is a possibility that they will ask you the range 185 to 400 nanometers. For the visible range it is 400 to 700 nanometers, and for IR it is 700 to 15,000 nanometers. Now a light source, they are going to make use of a tungsten lamp as a light source. Then in spectrophotometer, a white light is allowed to pass through a prism after passing through the collimator, that is the lens. It will fall on the monochromator. Here monochromator means monochromatic, it is related to that. So they are going to make use of a prism or grating element, either prism or grating element. The white light will fall on the prism, you know. The result is you will get all the 7 colors, so spectrum of 7 colors, of which composed of all they are going to make use of a particular color, and that particular color will pass through a slit, then it will fall on the sample solution, and a part of the incident ray will be absorbed by the solution, and the part will be remaining will be transmitted out, and it will be detected by the photocell. The working of the photocell is that whatever photons is falling on that cell, it will convert it into electrical signal, and ultimately the whatever reading the photocell reads, it will be displayed in the digital display or the meter. From there you can take the printout. This is the basic working of spectrophotometer, and in particular we are using single beam spectrophotometer. Double beam spectrophotometer. Double beam spectrophotometer, the video of the double beam spectrophotometer I gave, it is already there in my YouTube channel. Just go through that. But here I want to only say that it is double beam means they are not going to make use of two different beams. If they are going to use the same beam, but the beam will operate in one direction for a certain period of time, and the rest of period of the time it will operate in another direction. That is only meaning of double beam. So same beam they are going to make use of. Make use in double beam spectrophotometer. That means a type of a beam splitter is available over there, and again it will pass through monochromator, and some chopper will be there. It will chop the beam in a particular direction and it will go into the another direction. And in this case it allow there is a reference tube. Means here the test tube will contain nothing. It is a blank tube, and in other there's a sample solution is there, and both the rays they will collect at meet at one point after multiple reflection, and it will be fed into the detector, that is a photo detector. There this ray is working in a synchronization. Reference beam and the beam from the sample solution both are coming, and there is some synchronization is there between these two. And here the spectrometer is going to record the ratio of the reference to the sample solution. Very important. The word is the double beam spectrophotometer is going to record the ratio of the reference and the sample solution. It will be fed into the photo detector. The photo detector will detect the photons and it will convert it into electrical signals, and ultimately whatever signal is coming from the photo cell, it fed into the computer, that is a signal processor, and you can take the printout, or you can see directly the image in a digital mode. Some distinguishing characters of colorimeter. In colorimeter, as the name suggests, they are going to make use of a colored solution. Apart from color solution, some other things are there. The first is colorimeter. Color filters are going to use. As they are going to use tungsten filament, tungsten light, they are going to get the white light. And the filtering of in the system we don't need all the colors. So a color filter will filter. It will allow only a particular wavelength to pass through. So that is the use of color filter. Second is the radiation emerging out of the filter having wavelength within a small range. Here the wavelength is of very small range, that is of the order of 20 to 50 nanometers. In colorimeter, photocells are used as a detector. Here whatever light is coming out of the solution, it will fall on the photocells. Very important. Photocells are used. Photocell will convert the light energy into the equivalent electrical signal. And here they are going, the mode of operation means here they are going to use visible range, visible region. Here the Beer's Lambert law is partially obeyed. It is not fully obeyed. It is only partially obeyed. And I already told colorimeters are used for quantitative analysis of the colored substance. So here we can only analyze the color substance. If it is a colorless substance, then they need to add some coloring agent so that the colorless substance can be converted into a colorful substance, and later on they can determine its parameters. Here in spectrophotometer, they are using monochromator. Monochromator either can be a prism or grating element in order to get a monochromatic wavelength. And second distinguishing character is it is making use of narrow wavelength range, that is the bandwidth is less than 1 nanometer. Very important distinguishing point. In this spectrophotometer, they are going to use a photo multiplier tube. It's very important here. They are going to make use of photo multiplier tube. They are using in a visible UV and IR region. And here in this Beer-Lambert law is perfectly obeyed. Very important distinguishing point for spectrophotometer is Beer-Lambert's law is perfectly obeyed. And these spectrophotometers are used for the quantitative analysis and structural analysis of the colored as well as colorless substance. It can be used for both the system colored and colorless substance. There is no hindrance that we can make use of only the color substance. Here colorless substance can also be analyzed. The concentration of solute in the colorless solution can also be analyzed in the spectrophotometer. pH meter. Now and then everywhere we are making use of the word pH. So what is pH meter? pH meter is an electronic instrument used to measure the pH of the solution. and it is defined as negative logarithm of hydrogen ion concentration. It is very important. Negative logarithm of hydrogen ion concentration, pH is equal to minus log H plus, that is H ion concentration. pH is the power of hydrogen ion concentration, where P is the power, H is the hydrogen ion concentration. pH meter, it is based on the electrochemical principle. Very important. Again, MCQ based on this can be asked. Electrochemical principle. pH meter is working on electrochemical principle. And in this, they are going to make use of two suitable electrodes are placed in aqueous solution. Very important, is placed in aqueous solution. When two suitable electrodes are kept in aqueous solution, a potential difference will be generated between these two electrodes, and it depends on the activity of the hydrogen ion present in the solution. So this potential difference will be set between these electrodes, which will depend on, very important, the activity of hydrogen ion in that solution. The pH of a pure solution is 7, the pH of a normal acid is 0, and the pH of one normal alkali is 14. So the range of the pH scale is between 0 to 14, means it will start from 0 and it will end at 14. And 7 indicate that the pH of a neutral solution, means the pH of the neutral solution is 7. If it is less than 7, then the solution is acidic in nature. And if it is more than 7, then it is alkaline in nature. It's very important. Glass electrode and calomel electrode. This is another type of a combination to measure the pH. So one electrode is of glass and second is of calomel type. The glass electrode has a hard glass tube. At the base it has thin bulb, and in the bulb it is 0.1 normal HCl is kept there. The bulb is covered by a special membrane of soda glass, and very important, this HCl means it is sensitive to H plus ion, and it allows H plus ions to pass through it. And a platinum wire they are going to make use, and it is connected to a HCl through a silver chloride electrode. The wire coming out of the glass electrode is connected to the power pack of the pH meter. The reference electrode is the Calomel electrode, and it is not sensitive to H plus ion. It is only the HCl. In HCl, H is there, hence it is sensitive to H plus ions, whereas in Calomel there is no H, hence it is not sensitive to H plus ion. It contains calomel, as the name indicates. It is the mercurous chloride. Mercurous chloride, another name is the calomel, and hence we are making use of the word calomel, and hence the name is given as calomel electrode. Calomel electrode is connected with a platinum wire through mercury. The free end of the calomel electrode has a porous plug. The base of the electrode is deposited with the crystal. The remaining it is filled with KCl solution. The glass electrode in the test solution constitute half cell, and the calomel electrode constitute the half cell. These two half cell and half cell will make the one full cell, and hence the circuit will complete. And the circuit is completed by the two electrode, and ultimately the hydrogen ion concentration can be measured with the help of this system, and the system is the glass electrode and the calomel electrode. The electromotive force of the complete cell is given by E is equal to E reference minus E glass, where E reference is the potential of the reference electrode, that is the calomel electrode, and which is about 0.250 volt at room temperature, and E glass is the potential of the electrode of the glass, and it depends on the pH of the test solution, because this glass contains HCl and there H is there. If there any change in the aqueous solution, the H plus ion, if there is any change in the H plus ion in the aqueous solution, then it will ultimately affect the E glass, and ultimately the equation will get changed. Then the pH of the solution can be determined by the following equation: pH is equal to E glass minus E reference divided by 0.059 at 25 degrees Celsius. They can ask the this formula, mathematical statement they can ask you. It is important, 25 degrees Celsius. It is temperature dependent system, hence it is very important to write at 25 degrees Celsius. pH can also be written as pH is equal to E glass minus 0.250 volt divided by 0.059 at 25 degree Celsius. The glass electrode contains, very important, glass electrode contains Ag, AgCl and HCl. And the following reactions takes place inside this. Ag will it is a two-way reaction. Ag to Ag plus E minus, AgCl, Ag plus Cl minus. HCl will break down into H plus Cl minus. All the above three reactions are balanced. Very important, these three equations are balanced. In the glass electrode, H plus ions, as you can see from the equation number 3, H plus ions are generated. So H plus ion is generated in the glass electrode. In Calomel electrode, it contains Hg, Hg2Cl2 and KCl, and the following reaction takes place: Hg2 Hg plus E minus. Hg2Cl2 will give you 2Hg plus 2Cl minus, and KCl will break down into K plus Cl minus. Here there is no H plus concentration, hence it is not affected by presence of 8 hydrogen ions. Now we saw glass electrode and Calomel electrode. There is another type of electrode which is called as combined electrode, in which both the electrodes are not separated from each other. They are in one single unit. So combined electrode consists of glass and a reference electrode in a single unit. And the advantage of this electrode is that a smaller volume of the solution can be measured. And the disadvantage is, if any of the system fails, then we need to discard the entire system. We cannot repair, and we cannot make use the system in a further use. So we need to discard. If any of the element fails, then we need to discard the entire system. So this is all about the combined electrode. Centrifuge measurement, an apparatus that rotate at a very high speed and by centrifugal forces separate the substance of different densities. If you have any solution containing different densities, and if we rotate it at a very high speed, then the different density will settle at a different levels. The heavier will settle at the bottom and the lighter will settle at the top. Likewise, you can separate, and we can study that. So this procedure is called as centrifuge measurement. A centrifuge separates heterogeneous mixture of solid and liquid by centrifugation. Means the apparatus will be rotated at a particular speed, and you can separate the things. Centrifugation is a process in which a solution is rotated in circles around a central axis. Very important, the word is central axis. In centrifuge measurement, a glass or a plastic tube is used to keep the specimen. The test tube swings in a slanted or a horizontal position with the open end towards the axis of rotation. Towards the open end of the tube will always face the axis of rotation towards the center. The centrifugal force and the gravitational force act together in the solution. We all know the centrifugal, when it is rotated, when the solution is rotated with a very high speed, then the centrifugal force will come into picture. At the same time, we all are experiences the gravitational pull. So both the forces will come into picture, and this ultimately will make the heavier to settle first, and later on the lighter particle to settle on the heavier particle, and likewise the gradual settlement will start. So this is all the procedure about the centrifugal measurement. And in this, two forces, very important, two forces come into picture. That is the centrifugal force because of the rotation of the tube with a very high speed, and second is the gravitational forces. So two forces, centrifugal force and gravitational force. This result, the heavier solid part of the solution settles in the bottom of the tube, and the lighter part form a layer on the top. Centrifuge, this process, there are three types available. First is the low speed centrifuge, second is the high speed centrifuge, and third is the ultra centrifuge. So there it is divided into three. First is low speed. If it is moving with a very low speed, we will see the RPM afterwards. So if it is moving with a very low speed, then we can say it is a low speed centrifuge. If it is having higher than the speed of the first one, then we can say it is as a high speed centrifuge. And if it is having more speed than high speed, then we can say it as ultra centrifuge. First is the low speed centrifuge. The low speed centrifuge is used for the routine sedimentation of heavy particles. The centrifuge that rotates the sample at a maximum speed of 4000 to 5000. You need to remember this 4000 to 5000 RPM is for low speed centrifuge. And this instrument usually operate at a room temperature with no means of temperature control. There is no temperature controller is available for this. And it is used for the separation of cell organelles. Very important. It is used for cell organelles which is having high molecular weight and large size. High speed centrifuge. High speed centrifuge is used in more sophisticated biochemical applications. It is having higher speed of about 25,000 RPM, 25,000 revolution per minute, and it need temperature control, which hence temperature control is provided, which required for the sensitive chemical samples. Ultra centrifuge. As the name indicates, it is having ultra speed that is of about 60,000 RPM, and it is also known as ultra centrifuge or ultra speed centrifuge. And when something is rotated with a very high speed of 60,000 RPM, huge amount of heat will be generated. When huge amount of heat is generated, it will ultimately affect the samples. The sample property will change. Hence, we need refrigeration system. Hence, refrigeration system is attached to this. And the separation of molecules using ultracentrifuge is called as ultracentrifugation. And it was devised by Swedberg in 1920. Maybe they can ask this MCQ. Ultracentrifugation is a separation of particles suspended in a solution by rotating them with a very high speed of about 60,000 RPM. Very important, 60,000 RPM, and intense heat will be generated. Hence, refrigeration system is needed. The centrifuge consists of two things. One is motor and the rotor. The sample to be separated is placed in the rotor, and the motor makes the rotor to spin. The spinning produced, because of the spinning, because of having the RPM 25,000, 60,000, it depends on what kind of centrifuge method we are making use. Either it can be low speed, high speed, or ultra high speed. The spinning produces a force called as centrifugal force, which is pseudo force, and this force which causes a substance in a spinning round an axis to move away from the center. It will move away from the center, and it is called a centrifugal force. This force is called a centrifugal force, which is a pseudo force, and the centrifugal force causes the substance to move away from the axis more rapidly. So whatever I did in a bold letter words are very important with respect to MCQ type. So remember it. Next is the relative centrifugal force, RCF, or G force. Another name for the relative centrifugal force is G force. The force acting radially outward, very important, it is acting radially outward on a body moving in a circle is called as centrifugal force. And the centrifugal force depend on the angular velocity, that is rotation per minute, and radius, distance between the central axis and the particle. This you need to learn. Centrifugal force is equal to angular velocity square into radius, that is F is equal to omega square into R, where omega is the angular velocity, and which can be calculated as follows. Omega is equal to 2 pi into RPM divided by 60, that is rotation per second. Very important, they can ask numerical based on this formula. Otherwise, also remember this formula from multiple choice question point of view. The speed of the centrifuge is expressed as RPM, that is revolution per second. The greater the speed, the greater will be the centrifugal force. Very important, again MCQ can be asked on this line. The greater the RPM, the greater will be the centrifugal force. If it is less RPM you are making use, then less force will be generated. The longer the radius of rotation, the greater will be the centrifugal force. If it is short then of the radius, then the less amount of centrifugal force will be generated. The radial force generated by the spinning rotor is expressed in terms of relative to the Earth's gravitational force. Hence, it is called as relative centrifuge force, RCF, or G force. Because Earth's gravitational force, we know that it is denoted by G. Hence, it is called as G force or the relative centrifuge force. RCF is dependent on the speed of the rotation in RPM and the distance of the particle from the center of rotation. When the speed of the rotation is given in RPM and the distance are expressed in centimeter, RCF can be calculated by the formula, very important formula. RCF is equal to 11.18 into R, n upon 1000 the whole square, V unit. Very important. You need to learn this from numerical point of view also. We are going to make use of sedimentation rate. The movement of the particle in a centrifugal field is called as sedimentation. Very important. The movement of the particle in a centrifugal force is called as sedimentation. The particles settle because of the gravity. As I told you, two forces will come into picture. That is, one is the centrifugal force and second is the gravity, acceleration due to gravity. And this makes the heavier particle to settle first. The particles settle because of the gravity. And the rate of the movement of the particle is called as sedimentation, and the rate with which the particle settles is called as sedimentation rate. And the sedimentation rate depend on, very important, the size and the density of the particle. Again, multiple choice can be asked from this line. The larger and the denser settles first and followed by the smaller one. So very important, this is followed by the smaller and less denser one. The sedimented particle is called as pallet. Very important, pallet. The solution above the pallet is called as supernatant. Very important, in other words. The particles settle because of the gravitational pull, and the spinning increases the gravitational pull. Very important, spinning increases the gravitational pull, and a number of multiple choice can be asked upon this topic. The rate of sedimentation depends on, very important, four things are there. First is the density of the particle, second the size of the particle, third the viscosity of the medium, and fourth the gravitational pull. So these four things you need to remember very nicely, because based on this they can ask MCQ. So rate of sedimentation depends on, first the density of the particle, and second is the size of the particle, third is the viscosity, and fourth is the gravitational pull. The sedimentation rate of a given particle is given by another formula. You need to learn very nicely. V is equal to 2 by 9 into Rp square, rho P minus rho M upon eta into gravity. B is the rate of sedimentation. G is gravitational constant. 2 by 9 is the shape factor constant for a spherical particle. Rho P is the density of the particle. R rho is the radius of the particle. Rho M is the density of the medium. And eta is the viscosity. Centrifuge measurement, the instrument consists of motor, rotor, and the sample holder. There are two types of angle holders, very important. The first is the angle type, second is the swinging bucket type. When you read your textbook, you can make use these two types. One is the angle, it is making certain angle. We can make use of 30-degree angle. It is rotate, the test tube will rotate with an angle of 30 degrees. As I already told, in the angle type, the sample holders are fixed and are found at an angle of 30. They are rotated at an angle of 30 degrees from the central axis. So this I covered the bio instruments. Dear students, I again request you to read the textbook. It will be better for you, because you can remember things when you read the things. So at least for 2 times you read the textbook. Thank you.